Okay, part B of this question says how much time it spends in the air. So this again, when we're looking at how much time it spends in the air, since it's going up and down, we're going to look vertically again. We're going to look at all the vertical components. There's actually 3 different ways we can do this question, probably more, but 3 for sure that we can do. So in the first one, we're going to assume that when the ball strikes the ground, it's traveling at the same velocity, only the opposite direction, as when it left the ground. And we looked about this a little bit with gravity. When it leaves your hand, it's moving up. Then when it comes back down, it's moving just as much down in velocity as when you originally threw it up, just as negative. Okay, so it's using that idea as the first way we're going to do this. Okay, so let's look at this. I have my acceleration is equal to v final minus v initial over the time. Solving for time, I multiply both sides by t and then divide by a. Okay, so my final velocity is going to be, and again, we're thinking vertical, so we're thinking right here, is going to be negative 12.8. 855 and all that change meters per second. And then I'm going to subtract my initial velocity of 12.855 and all that change over my acceleration, which is negative 9.80 meters per second. When I calculate this out, round it, I get 2.62 seconds. Okay, so take a second, try that out. Now, let's try this question another method, knowing we got that. See if I can erase this all. Okay, method 2. We're going to calculate the time it gets to the halfway point. So that ball goes up halfway. Couple things we know about that halfway. Its velocity at the very top is 0. And we saw that when we looked at gravity. At its highest point, it has stopped. Its instantaneous velocity is 0. So we're only going to assume how long it takes to get halfway up, and then we're going to multiply by 2, because it's going to take just as far to get up as it is to get back down. Okay, so that's what we're going to do on this question. So looking at vertically, my V final is going to be 0. My V initial vertically was right here, 12.855 and all that change. Okay, and my acceleration due to gravity is still negative 9.8 meters per second squared. So using the same formula, A equals V final minus V initial all over time. Solving for time. So I'm multiplying both sides by time and dividing both sides by A. Okay, that was kind of messy, sorry. V final minus V initial over acceleration. Putting in the values. V final we said was 0. Subtract 12.855. I would actually put in all the decimals when I go to do this. Meters per second divided by negative 9.80 meters per second squared. I would get my time to be 1.3 seconds. Then multiply by 2. And when I rounded that off, I would get 2.6 seconds. Exactly the same as I got the other method. Okay? And finally, there's a third method we could use to solve this problem. Okay, and this third method says we assume that the ball strikes the ground at the same height it left the ground from. Well, that makes sense. I kick the ball, I come back here, that's at the same. So my displacement My total displacement, even though I've gone up and back down, is 0 meters. Okay, I know my initial velocity, I calculated it right here, 12.855 and all that change meters per second. I know my acceleration in the vertical is negative 9.80 meters per second squared. And what I want to know is time. So is there some formula that has time, acceleration, initial velocity, and displacement? Let's look at this first one. Displacement, initial velocity, time, acceleration. Well, there's one. This one is looking, there's no acceleration though, so we're not going to use that one. We're going to try this formula. Okay, so my formula was displacement equals VIT plus 1/2 AT squared. Okay, we said displacement was 0. V1T plus 1/2 AT squared. Okay, moving this section to the other side, we're going to subtract. Okay, remember I want to get time all by itself. I can divide both sides by time here. So I would get negative VI equals 1/2 AT, because time squared divided by time. I'm still trying to get time by itself, so I'm going to multiply both sides by 2a. So negative 2a initial velocity equals time. Sorry, I'm dividing by a. I just about tried to do 2 steps at once. So I times by 2 to get rid of here, and then I divide by a. There we go. So negative 2, my initial velocity is that 12.855, all that junk. And I would actually put it in to do a good job. I'm just showing that we can do a bunch of different methods here. And then I have negative 9.80 meters per second squared is equal to time. Can anyone guess before I even do my calculator what I'm going to get? When I round it off, I get 2.6 seconds again. So my whole point is saying you have all of these formulas that you can use dependent on the information you've given. So you have to just think about what you know. You have to analyze, okay, is this motion vertical or horizontal? And that sometimes there's many ways to get to that same answer. Okay? Unrounded for each of these methods, I got 2.62094845, I believe is what I got. Yeah, so just know that unrounded you're going to get more, but rounded 2.6. Okay, so a couple ways to solve how long it was in the air.